afternoon, STEAMologists. This is Miss Cheever, the STEAMologist at Boyd Elementary. Today we're going to be investigating exploding bags. So your materials that you will need today for today's experiment include vinegar, baking soda, water, plastic bags, plastic Ziploc bags that is, toilet paper, measuring cups, and spoons, okay? So make sure you gather all your materials before you get started with the experiment today. So today we're going to be investigating our objective, which states we're going to explore the properties of a chemical reaction. So throughout our STEAM adventures this semester, this quarter, we've been investigating chemistry. So with chemistry, we've mainly been focusing on the study of matter. So today we are investigating a liquid, vinegar, creating a mixture with water. Then we have our solid right here, which is baking soda, all right? So all of these are household tools that you should have in your kitchen, including your toilet paper you should have at your house, and hopefully you have some Ziploc bags. You do need a Ziploc bag nearby, okay? So these are very easy tools and materials to get on your hands to, so you can actually investigate exploding bags, all right? So what happens when a bag explodes? What do you think? Why do you think this experiment is called exploding bags? So today, during your Google survey, your quiz, I'll be asking you to make a prediction about what you thought would happen, all right? So the word explode signifies that something is happening with our bag here, all right? We're putting something inside of our bag. So earlier you heard me state that vinegar and water together are two different substances. However, when I combine them, I create a mixture, all right? So is that a physical property or a chemical property? So I'm creating vinegar, a mixture of vinegar and water, all right? That will also be a question in your Google survey form today. When I combine the baking soda to it, what changes will occur, do you think? Vinegar, water, baking soda. What changes do you think will occur? Have you ever mixed vinegar and baking soda together? Some of you may have had that experience before. What did you observe happening to the baking soda once vinegar was added? All right? How do we know it is a chemical reaction? What are some signs of a chemical reaction? So today, the description of our activity states we're going to combine vinegar and baking soda within a plastic bag to initiate a chemical reaction. All right? Initiate means to start. So let's take a look at our experiment. For our experiment, we're going to tear out 2 pieces of toilet paper from a paper towel roll. So that's basically 2 squares. So I have a fresh new paper towel roll here. All right, so 2 pieces. It's 2. If you plan on doing more than 1 bag, you will need another 2 pieces. All right, so I'm going to do 2 bags today. So I have 2 pieces of toilet paper. All right. So now, it says add a large spoonful of baking soda to the center of the toilet paper squares and carefully wrap the toilet paper around it. All right. So here's my baking soda. I'm going to take a spoonful. Okay, here's my spoonful. I'm placing it in the center of the paper towel roll. In the center of the paper towel roll. All right, our next step is to wrap the second toilet paper square around the first one. So you're going to wrap. So that means we need another piece of paper towel roll. So we can wrap it again. We're wrapping it twice. Think to yourself, why do you think we're wrapping the toilet paper twice? Why do you think we are wrapping the toilet paper around it twice? So this is once. placing this inside the second one. And now that is twice. I want to do the same thing to my second paper towel. Wrapping it once, and then wrapping it twice. What does wrapping it do? Wrapping to me is some type of protection, all right? Prevent something from getting in, all right? Wrapping. All right, so next, we're going to hold the plastic bag open, and we're going to pour 1/4 cup of vinegar and 1/4 cup of warm water to the bag. So before I started my video, I have a tea kettle here that I warmed to 100 degrees, and I have some warm water inside of this container, all right? Now I have water in this container as well, and it's room temperature water. So I have room temperature water and warm water, okay? So for this experiment, I'm going to change the variable, all right? So for one bag, I'm going to use room temperature water, and for the other bag, I'm going to use warm water, all right? My other liquid that I'm going to use is vinegar. I'm going to use the same amount of water, warm water and room temperature water, and I want to use the same amount of vinegar, 1/4 cup, okay? I'm gonna go ahead and open up one bag, Ziploc bag, and open up the second one, so it'll be ready for me to pour the water inside and the vinegar inside. All right, so I'm gonna sit that beside my wrapped baking soda. All right, so now the room temperature water, I'm going to pour 1/4, and I have some small cups right here that I'm going to use to help me pour the water and vinegar inside the bag. So 1/4. 1/4 is a fraction. Think to yourself, what percent is 1/4? What percent is 1/4? All right, you're right, that's 25%. 1/4 is 25%. So in this container I have room temperature water, I put that to the side. And now I'm going to go over here and pour my warm water. As you can see, there's some vapor coming from here, so it's definitely warm water. All right, so now I'm going to pour that inside of a small cup right here. A little bit more. I also wore gloves today because we're working with warm water and working with a chemical. That chemical is vinegar, the household product here. All right, so now we're going to take another cup and measure 1/4 cup of vinegar. All right, so my cup over here, cup over here. This is definitely vinegar. I can smell that strong odor. All right, so now I have my second cup here. Room temperature water, vinegar. One-4 cup. All right, warm water and vinegar, okay? All right, next, you may need another person to help or assist you with this next step. So now that we have our vinegar and our warm water and our vinegar and our room temperature water, we're going to place these inside of the bag, okay? So you're actually going to open up the bag and pour the vinegar and the warm water inside of one bag and the vinegar and the room temperature water inside the other bag. room temperature water. So I'm gonna hold that down to the table, so as I pour, the bag does not move or falter, okay? Now, this one over here, hold the bag down to the table, vinegar, and warm water. All right, so both require you to place the actual wrap baking soda inside the bag and zip it up quickly, okay? So now you can see what's happening over here. You may see some bubbles form. Now the bag is expanding. And we can see that the baking soda that was in the wrapped toilet paper is now being dissolved in the vinegar and the warm water. You may also see some vapor that's starting to actually come up on the sides of the bag. That's a part of the water cycle, all right? And now we see some condensation as well. You may see droplets of water forming on the actual inside of the bag. All right, so why is this called exploding bags? That was my initial question. So here's the room temperature one. It says zip it up very fast. Quickly, quickly, quickly. Room temperature. So this bag right here is warm to touch because maybe of the warm water. While this bag over here is cold to touch, maybe because I use room temperature water. So it looks like we still may have some baking soda still dissolving inside of each Ziploc bag. So what do you think caused the bag to expand? What do you think caused the bag to expand? And why is the actual bag that I'm holding here cool to touch? Why is it cold? What's actually going on inside of the bag that's causing a temperature change, all right? So we're investigating the properties of a chemical reaction. What's one thing that you saw happen as I added the toilet paper roll of baking soda? It started to dissolve. I actually heard or hear some sizzling or fizzing, and I see bubbles that form, okay? And it looks like something was given off as well because the bag expanded. What is taking up space inside this bag? What changed inside this bag? So, baking soda and vinegar and water, what does it produce? It produces a gas. You've seen this gas, and we've talked about this gas throughout our STEAM adventures. This gas is called carbon dioxide. So inside of each one of these bags, I have carbon dioxide. The carbon dioxide was given off when the reaction took place between the baking soda, the water, and the vinegar. Then the particles of the gas began to expand and actually take up space inside of the bag. That's also called volume. So when that happened, as a result, the bag started to expand, okay? Maybe if we do it again and zip up the bag faster, we may see the bag explode, okay? You all wanna see the bag explode? Let's try to do it one more time and see if that happens. So I have my 2 paper towel rolls. This time I'm just going to use warm water. Okay, have a spoonful of baking soda. There's my baking soda. Wrapping it once. Wrapping it twice. What do you think happens if I do not zip up the bag quickly? All right, when the reaction starts to take place. Because immediately we know that this toilet paper is going to get wet up, okay? That's what it's doing because it's so soft. The water is going to hit it, the mixture of the water and baking soda, and help it dissolve quicker. So here's my warm water. and the vinegar. I have another question. Why do we need warm water? Warm water versus cold water. The molecules in warm water, they move faster than the molecules in cold water, all right? So the molecules are moving fast. Maybe it's gonna cause a reaction to happen fast. All right, I have both liquids inside. Now I have a mixture of vinegar and water. And now put in my all right, so now this bag seems a little less flated than this bag, all right? What happened? Remember it said zip up the bag quickly. So if you do not zip up the bag quickly, what does that allow to happen? Why didn't this bag explode? All right, think about that question, and I'll see you again next Friday talking about STEAM Adventures. We're going to continue our discussion about chemistry and continue talking about different types of reactions that take place in a chemical reaction. And as we think about the chemical reaction today, what can you change to allow this bag to actually explode? Because I want to see that bag explode, all right? Thanks for tuning in to the STEAM Adventures. See you all next time.